Hello students, today I am going to cover up one of the CPU scheduling algorithm that is known as the priority scheduling. Priority scheduling means preference. When a number of tasks are executing simultaneously, to which task we will give the preference or which task has the higher priority to execute first. Some tasks are the user-defined task and some tasks are the system-defined task. In general, the system-defined task always runs in the background. We can check it using the task manager. So most of the time, the system defined tasks have the higher priority than the user defined priority. The priority value we can also set or default priority. Otherwise, when we are submitting a job to the operating system, it will execute by default priority. In Linux, there is a command that is known as the nice, NICE, or also in the Unix. So it has the predefined value. For example, in SEO Unix, the nice value varies from 0 to 20, 0 to 19. So the 0 has the highest priority and 19 has the lowest priority. By default, the process execute on the priority 10. So we will cover up later in the practical session, not here, but here I am discussing the only the priority scheduling. So the SGF algorithm is a special case of priority scheduling algorithm. So here we are dealing with the priority, although the priority is associated with each of the process, and CPU allocated to the process that have the highest priority. Equal priority processes are scheduled in FCFS manner, like in the SJF. If two or more processes have the equal priority, then whatever the process come first will execute first. In general, priority ranges from 0 to 7, 0 to 19, 0 to 4, 4095, and so on. As I have given the example, in SEO Unix, it varies from 0 to 19. However, there is no general agreement on the whether the process that have the priority 0 is the highest or the process that have the number 19 as in SEO Unix has the lowest priority. So priority may be defined by the operating system designer. 0 may be considered as the highest priority or 0 may be considered as the lowest priority. Sometimes this may be possible. The priority range may vary from -20 to 19. So 0 will be the normal priority, -19 may be least or maybe highest. So it depends on the operating system designer. As in the book of Galvin, the 0 is considered as the highest priority and the number that is the largest has the lowest priority. So priority algorithm again classify into two types. First one is the preemptive and second one is the non-preemptive. Just like the SJF algorithm we have gone through in the previous video. So firstly, we are dealing with the non-preemptive. In the non-preemptive priority algorithm, once a process is assigned to a particular task, once the processor is assigned to a particular task or the process, it cannot be preempted until the process which is executing will not leave the processor itself. Means until the process that is executing will not complete its execution, there is no process that can snatch the processor from that. While in case of primitive, if a higher priority process arrives, the lower priority process which is executing a process will be snatched. That means processor will be snatched from that process and allocated to the higher order priority. So we can see how the priority can be defined. So this is one queue, this is the another queue, this is the third queue. So queue is 1, 2, 3. I have numbered 1 as the highest priority and 3 as the lowest priority. If a process, in case of non-preemptive, if a process is executing, X is executing, and suppose that meanwhile, during the execution, it takes 6 millisecond, and after 2 millisecond, a process Y arrives that requires 2 or 10. The time doesn't matters. A higher priority, a process arrives in the higher level queue, which have the higher priority. So in the non-preemptive, until this process X will not get complete its execution, the higher order priority process cannot snatch the processor from the process X. While in case of primitive, as the process appears in the higher order priority queue, it will immediately snatch. For example, after the 2 second, a process appears in the higher order process. So processor will be snatched from the process X and allocated to the higher order process, that is the Y. So this is the basic concept in case of priority scheduling. Now, advantage. It consists of priority of process and allows the important process to run first. Priority scheduling is primitive in mode. Primitive mode is the best suited for the real-time application. Real-time application where the higher order priority must execute first, while we can delay the lower order priority process. So this is the best example for the real-time operating system. While disadvantages are, process with the lesser priority may starve for the CPU, because this may be possible. Always the process in the higher order priority queue appears continuously, so lower order process may wait for a longer amount of time and may comes into the starvation condition. There is no idea of response time or the waiting time, because as the process are appearing in the higher order, so average waiting time will get increased, or turnaround time also, response time will also increases. So there is no idea in the beginning of the scheduling. Now consider the example with non-preemptive. Here there are 5 processes. We have to again find out the average waiting time and average turnaround time for this process. So here are the 5 processes: P1, P2, P3, P4 and P5. The arrival time is given, the bus time is given, and priority is given. Here, firstly, we have to draw the Gantt chart. At the time 0, at the time 0, there is only one process, that is P1. So since there is no other process in the ready queue, so it will get executed, and it is a non-preemptive, means until the process P1 not get complete, no one can snatch the processor from the process P1. So P1 process will execute its entire life, entire bus time, and get finished. When it will get finished, it can be observed there are a process, all processes are in the ready queue. So now it will search for the higher order priority. So here it is considered the higher number as a higher priority. So there are two processes that have the same priority, that is 5, which is the highest one. So any one of them can execute, but here there is a tie in the priority. So the process which have the lower number will get execute first. So P4 will get execute first. So P4 will execute for the 5 amount of time. So this is the process P4. Then after there is this priority of P5. Then P5 will get execute and it will become 0. So it will take 2 unit of time. Then after the remaining process are two, P2 and P3, we will again check for the priority. Here 4 is the priority for the process P3. Then P3 will get execute. It requires only one unit of time, so it will execute. And at the last the process P2 will get execute that requires 3 unit of time. So this is the concept behind the priority algorithm. Now we have to find out the turnaround time and waiting time for each process. So as we know that formula we have discussed earlier, turnaround time is equal to completion time or exit time minus arrival time. So here for the process P1, the completion time is 4, so 4, and arrival time is the 0. So it will have the turnaround time 4. Now for process P2, P2 will complete at the time 15 and its arrival time is 1. So it will execute. Then after process P3. P3 has its completion time as 12 and it's arrive at the 2 unit of time. So 12 minus 2, 10. Similarly, process P4 has the completion time 9 and it arrives at 3. So 9 minus 3 is equal to 6. And for process P5, P5 has the completion time as 11 and it arrives at 4. So 11 minus 4, it is 7. Now, for the waiting time we can calculate using the formula turnaround time minus bus time. Turnaround time minus bus time. So for the process P1, the turnaround time is the 4 and its bus time is also 4. So 4 minus 4 is 0. Similarly for process P2, its turnaround time is the 14 and its bus time is the 3. 14 minus 3, that means 11. For process P3, turnaround time is 10 and minus its bus time is the 1. So 10 minus 1 is equal to 9. And for the process P4, the turnaround time is 6 minus the execution time, that is 5. So 6 minus 5, 1. And at the last, the for process P5, the turnaround time is the 7 minus bus time, that was 2. So 7 minus 2 is equal to 5. So this was the turnaround time and waiting time for each individual process. Now I have to find out the average. So I will sum up all the turnaround time for every process and then after divide by the number of processes that I have done here, 4 plus 14 plus 10 plus 6 plus 7 by 5, there are, because there are 5 number of processes, so I will get the average turnaround time. Similarly, average waiting time is the sum of waiting time 0 plus 11 plus 9 plus 1 plus 5 divided by number of processes, that is 5. So this is all about the non-preemptive. Now I am moving towards the preemptive example. This is the preemptive priority algorithm example. Again, we have to calculate the average waiting time and average turnaround time. Here, the higher number is considered as the higher priority, and there are 5 processes whose arrival time and burst time are given as follows, and along with the priority. Now, as the process P1 at the time 0, there is only single process that is executing. So process P1 is executing and it requires the 4 amount of time, but so it will execute. Here I am depicting by the figure. So process P1 will start to execute at the time 0. After 1 second, there is another process is coming. So I will check the priority of that process now. It has the priority 2. At the second, at the time of 1 unit, another process P2 arrives that have the priority 3. That means it have the higher priority. So automatically there will be a context switching. Now process will move from the processor will move from process P1 to P2. The P2 will execute for a, a second, because in the next second another process is coming at the 2. So for it will check for the priority of that process. So P2 is executing. Here it will check the priority of this process is 4, means higher than the priority of process P2, means process P3 has the higher priority than the P2. So again the processor will switch over from P2 to P3. So P3 requires only a single unit of time, so P3 will get execute now. At the next moment, at, at the next moment, when t is equal to 3, a new process P4 arrives in the ready queue. I will check whether that process has the higher priority or not. Yes, it has the higher priority. It has the higher priority, that means 5. So now the processor will again switch over to the process P4 now. At the P4, it will execute for a second, that means it remains 4. Again it will check at the hour 4, there is a new process. As the unit 4, there is a new process, whether it has the higher priority or not. During the identification, I have found these two processes have the same priority. When there is a same priority, then there is a tie. On the tie, the process that come first will execute continue. So the process P4 will continue its execution for the 4 more seconds. So total 5 seconds will it continue. So P4 will end at 8. Then after, the next higher priority process is the P5. So P5 will execute for 2 milliseconds, that means 10. And then after, the lower is the P2, P3 has completed, then P2 requires 2, so P2 will execute and it will 12. And then after, the remaining was the P1, so P1 will execute, it requires the 3, that means 15. So this will be the Gantt chart for the process. Now we have to find out the turnaround time and waiting time for each process. As we have done earlier, again we will follow the same formula for calculating the average turnaround time and average waiting time. The formula is defined as turnaround time is equal to completion time minus arrival time. The completion time for the process P1 is the 15 and arrival time is the 0, then 15. For process P2, completion time is the 12 and its arrival time is 1, so it is 11. For process P3, completion time is the 3 and its arrival time is 2, so turnaround time is 1. For the process P4, the completion time is 8 and its arrival time is 3, so 8 minus 3, 5. And the last one is the P5. P5 has the completion time as 10 and its arrival time is the 4, so 10 minus 4 is equal to 6. Now for calculating the waiting time, turnaround waiting time is the can be calculated as the turnaround time minus bus time. So turnaround time is as given as follows. Yeah, every process we have already calculated. So P1 15 minus bus time 4, that means 11. For process P2, 11 minus bus time is the 3, so 8. For process P3, it is 1 minus its execution time or the bus time, 1. 1 minus 1 is equal to 0. For the process P4, it is 5 and its bus time is also 5, so 5 minus 5, 0. For the process P5, its turnaround time is a 6 minus its bus time is a 2, so 4. Now, the average turnaround time and average waiting time we can find out as follows. We will sum all the turnaround time divided by the number of processes. Those are the 5. So 15 plus 11 plus 1 plus 5 plus 6 by 5, that is 7.6. And for the waiting time, average waiting time, 11 plus 8 plus 0 plus 4 divided by 5, that means 4.6. So by this method, we can calculate the average waiting time and average turnaround time in case of primitive priority algorithm. This is from my side. Thank you.